This example we're going to look at is adding two vectors together that aren't at right angles. So we're going to look at this question here, which is 12 newtons at 0 degrees added with 7 newtons at 120 degrees. First thing we do is we draw it roughly to scale. Here's our 12 newtons sitting up here at 0 degrees, and 7 newtons at 120 degrees is going to look something like that. The reason we want to draw it roughly to scale is so that we can have a good guess, because it's quite an important part of doing this. And our answer is going to sit up here. There's our answer there. We'll call that A. And of course we need to know the angle as well, because the vector not only has a magnitude, but it has a direction with it. The other important thing to do, to remember when doing these vectors, is to give yourself a lot of room, okay? Make sure you've got a big bit of paper. Don't try and do it too small in the corner of the paper. So the next step in here is we want to redraw this and convert it to right angle triangles. So what we have here is we've got a 12 newtons still going up. We'll keep that there, and we want to know these two steps here that make up this portion of 7 newtons. If they're all at right angles to each other, we can deal with them better. And to do that, we have to use our right angle triangle rules. So if that there is an angle of 120 degrees, and we make a right angle, that leaves that having an angle of 30 degrees. Once we've got our angle with a right angle triangle, the first step we always do is label. That's our opposite, that's going to be our adjacent, and that's our hypotenuse. So SOHCAHTOA tells us that our sine equals our opposite over our hypotenuse, our cosine equals the adjacent over the hypotenuse, and the tan equals the opposite over adjacent. In this case here, we need to know our opposite and our adjacent, and we know hypotenuse in each case. So the first thing we'll work out is our opposite. So if we get our finger here and we cover the opposite on this triangle, it tells us that the opposite equals sine times hypotenuse. And if we want to know what the adjacent is, it's cosine times hypotenuse. So let's use those two formulas. So the A will equal cosine 30 degrees times the hypotenuse, and the hypotenuse of course is 7 newtons. And then the opposite will equal the sine 30 times 7 newtons. Right, we put these in our calculator. Okay, let's do these in our calculator. So we go cosine 30 times 7 equals, and that gives us an answer of 6.06 newtons. And the next one is sine 30. So we'll do sine 30 times 7, giving us an answer of 3.5 newtons. Alright, let's redraw this now. So we've got 12 newtons going up. We've now got 6.06 newtons going across and 3.5 newtons going down. This 12 newtons and this 3.5 newtons are opposing forces, so we can minus the 3.5 off the 12 newtons and redraw it once more, and we wind up with 12 newtons minus 3.5 newtons, which gives us 8.5 newtons up and 6.06 newtons across. So where we've got to this is now we've just got two forces at right angles. So this situation here equates to this diagram here, two forces at right angles. And we can just resolve this by turning it into a right angle triangle. There's our answer there. We'll call that A, and there's the angle we require. And A will equal the square root of both the sides squared. 6.06 squared plus 8.5 squared. Pays to put that in brackets when you put in your calculator, and that gives us a force of 10.43 newtons. We still need to find the angle though, so let's look at that. Let's look at that last step of finding the angle. We'll just do it up here. back here we're looking for this angle here, and this here becomes our opposite when we label our sides. That becomes the adjacent, and that becomes the hypotenuse. We know all three sides, so we can use any formula. Formula I like to use though is tan, because we're sticking with these two numbers that we've run all the way through with. So let's look what tan says. We cover up tan. Tan says that the tan of the angle is equal to the opposite over adjacent. Let's write that down. Tan of the angle equals opposite over adjacent. We know those numbers. Opposite is 6.06 and tan is 8.5. In this situation here, what we've got is we've got the ratio here, but we don't have the angle. That's why we have to use the inverse function to find the angle when we know the ratio. So we use tan inverse of 6.06 over 8.5, and that will give us the angle in degrees. Let's have a look how we do that on our calculator. So on our calculator, what we want to do is we want to use tan inverse. To get to that, we use shift tan, and then we put in the value, shift tan, put a bracket in first, 6.06 divided by 8.5. 8.5 equals, and from that we get an angle, and the angle we get is 35.48 degrees. The answer to this question is our 10.43 newtons at 35.48 degrees.